All right, in this video, we're going to be taking a look at expressions and operators. Ooh, two new fancy words. Well, fancy perhaps, but nothing new in regards to what you've already seen. In fact, you've worked with expressions and operators as you put the Hyperion project together and that simple Windows application. You can think of expressions and operators as the basic building blocks when creating an application. Right, Logan?
Right, it's how you go about managing and storing data.
Okay, managing, working with, etc. So in this video, what we're going to do is first take a look at what expressions are. We're then going to take a look at what an operand is, because when talking about expressions and operators, we're going to throw out that fancy word operand. From there, we're going to take a look at how operators break down into different categories. We're going to talk about the assignment operators. We're going to talk about relational operators. We're going to look at mathematical operators. We're even going to look at, for just a second, some logical operators. And when I say look at, I'm talking about 2 seconds of whiteboard, the end. Why? Because I'm going to cover them later after you guys understand what if statements are. It'll just make a lot more sense. I don't want to confuse anybody in this particular video. And trust me, there's enough that we're going to be showing you that one or two of these operators might confuse a couple of you. Hopefully not. In the end, we're going to talk about operator precedence. This becomes very important because you need to know when evaluating an expression what gets evaluated first if it's a compound expression. So very important. If you are not aware of operator precedence, you may end up in a situation where you think the result is going to be something different than what you're actually getting. So that is the game plan. Now, let's go ahead and bring up the whiteboard, and we'll jump in here real quick. All right, we're ready to go. Let's start out by first taking a look at what an expression is. The definition of an expression is a combination of literal values, variables, and operators that are evaluated to a result. Here is a meaningless expression. X plus 5. That is indeed an expression. It's meaningless. Type this into the compiler and it's not going to be very happy because we're not really saying what to do. X plus 5, okay.
It's not so much that it's meaningless, it's incomplete in the sense of a program.
Well, with it being incomplete, it's kind of meaningless, wouldn't you say?
It can't be used on its own.
Precisely, because it can't be used on its own. But this is indeed an expression. So this is an expression that is using a variable, a literal type. I'm just going to say LT. Now, I've been throwing around that word literal type every now and then in a couple of these videos, and all that's saying is just, when we go in there and we say 5 or 15, that is a literal type. A variable, we all know what variables are now. Now, check this out. This right here is an operator. So we have a simple expression. Now, of course, if we wanted this to be meaningful, we could finish it off by adding another operator in here. Aha! And now, if we really want the line to truly be able to execute, we can put a terminator at the end. So now we have more of a compound expression where part of this expression is going to be evaluated first, and then finally the whole thing. So let's say x had a value of 2 in it. So what happens? 2 plus 5 gives us 7. So then you're looking at x equals 7. And then finally, here we are with the variable x containing a 7 after we hit that final evaluation of the expression, which is using the equals operator, the assignment operator. Okay? So with that, let's introduce the word operand. An operand is a literal value or variable that is used with operators to form expressions. Well, we know that this right here is an operator. This is a variable and this is a literal type, but they are operands. And this particular operator is looking for 2 operands to work. Right, Logan?
Right, I mean, you've got your operands right there. You have the 5 and the x. Those are your 2 operands, your 2 values that are being used in the operation.
You got it. Now, when talking about operators, they kind of break down into, well, we've got major categories and minor categories. And I'm just throwing that out there. Let's see. So major categories, as you saw a second ago, we're going to have things like the assignment operator. We'll have relational operators, mathematical operators, logical operators, etc. And we'll take a look at all of these categories. But all operators break down into 3 subcategories, if you will. And these subcategories are, now I'm going to throw some fancy words your way, the unary, the binary, and the ternary. Now, what the heck am I talking about here? Basically, what we're talking about is how many operands that operator is going to work on. So in this particular case where we had x plus 5, how many operands were required for this operator? 2, right? So in this particular case, this was a binary operator. Hopefully that makes sense. Now, watch this. Make it even more clear, x minus 5. Again, we're in another situation where it's just a very simple mathematical operator. So we're going to take x and subtract 5 away from it. Again, here we are with 2 operands required by this particular operator. So it is, again, a binary operator. But watch this. This is also valid. Isn't it, Logan?
Well, you've got another operator. In this case, the operator itself is represented by 2 characters. You have equals and minus. Okay, I was actually looking at that.
You're looking at it as a different
You have
one.
2 different operators in there. You have a minus operator in front of the 5, and then an equals assignment operator to take that value and put that into x.
Okay. Now, watch this. Let me break this out a little bit differently, just so Logan goes, I see what he's doing. What if I do this for you? X equals, I'm going to put a big space, minus x. How about that?
So then you'll essentially just reverse the sign on x, because you do that as an operation, but then you turn around and store that value inside of x.
Exactly. So here we are, again, using the minus operator, but this time, how many operands is it working with? It's working with only 1. So in this particular case, we're using a unary operator. So you can see the difference. You can see how this particular symbol used in an expression that requires 2 operands is a binary operator. But in this particular expression right here, because it's still an expression, our operator is a unary type because it's looking for only 1 operand. Is that pretty clear?
Right, and it might seem confusing because you might wonder, well, in what case are those going to be used? Why doesn't the unary get used in your x minus 5 example? And we'll get into that when we get into order of precedence.
We will. Okay, so this is just a very simple look. So as I go through each of the operators, what I'm going to do is I'm going to break down that operator in regards to how many operands is required. Does it require only 1? For example, if we had a line like x plus plus, terminator. Well, that's a situation where our operator is looking for only 1 operand, so it's a unary, just like we saw down here. Binary, and we've already seen an example of that. Ternary, we're not going to look at that in this video. Again, I need to get through conditional branching with you guys a little bit later, and then I'm going to go back and introduce a very cool ternary operator to you guys. But right now, I really feel that's kind of outside the scope of this video. Okay, so let's go ahead and bring up our whiteboard. And let's add in another sheet. Let's turn this sheet off. And let's do some more writing. So let's start out first with an assignment operator. An assignment operator. Very simple stuff. Guess what it looks like? The operator itself is an equal symbol. Just a 1 equal symbol. An example of it is x equals 5. Okay? What category does this fall into? It's very simple to figure it out. There we go. We'll start breaking this up for you. Hopefully by now, while I was drawing these really cool lines, you guys said, well, this operator requires 2 operands. By requiring 2 operands, it is a binary There you go. It's a binary operator. All right. So that is the assignment operator. What is the assignment operator's job? It is to take the value on the right and put it into what is on the left. So in this particular case, we know that we are representing a storage facility that is labeled X, and we are putting 5 into it. Assignment. That is what we are doing, an assignment. All right, so now what I'd like to do is let's move on to relational operators. Now, we do have some other assignment operators, but they work in conjunction with mathematical operators too, so we will be visiting those once we get into the mathematical operators section. So, relational. Operators. All right. So with relational operators, what do we have? So again, I'm just going to continue working on down. So our operator, the category, and let me give you some sort of example, like such. And my straight lines, how great do they look today? All right, so let's start out with this. Equals, equals. This is equality. Now, what I'd like to do with everything that I'm going to show you in here, pretend it's inside an if statement. Now, I know we haven't really covered if statements, though you have seen them in the Hyperion project, and we saw them in the bounce code in the Windows application that we put together. So we've got if, some sort of expression in here, and then stuff that we do if it evaluates to true. Okay? And we'll be covering if statements very soon in this course. So what needs to be inside these parentheses is basically a Boolean value, which that means true or false. Okay? So everything that I'm about to show you with relational operators, this is going to evaluate to a true or to a false. So equals, equals. Well, the category, all of these are going to fall into binary. So let's use an example. X equals 10. Well, let's assign X a value. So in our particular case for this example, here's going to be X. And how about inside X we put, let's just do a 10. All right, now to push this a little bit further, let's put the result right over here. Because remember, I said the expression they always evaluate. Expressions evaluate to some sort of result. In this case, they're going to evaluate to a true or to a false. It's going to evaluate to a Boolean answer. So, is X equal to 10? Notice how I read that. I'm going to use the word is, because remember, these are used quite commonly in if statements. So, is X currently equal to 10? Well, is it? The answer is yes. Well, since it's yes, the result would be true. Okay? This is equality. Please, ladies and gentlemen, be very careful. This bites beginners often. I promise you that. Why? Because a lot of people like to get in there and say, if X equals 5, we have a problem right here, don't we, Logan?
Right. Well, that's a mathematical assignment in that case, since we're dealing with integers with X and 5.
Yeah, we're using an assignment operator.
And the problem is, as well as storing 5 and X, that's also going to return the integer 5.
Right.
And you can't perform an if check on an integer. You have to do an if check on a Boolean.
Exactly.
So it's actually less of a problem in C# than it is in other languages, because C# will catch it and say, no, you can't compare an integer with a Boolean.
Right.
Whereas in other languages, you can evaluate an integer depending on how everything works. If you have a 1 or 0, you can still check that. So you could run into a case where you do an assignment, and then that returns something that if can check, and your code executes with no compiler errors. But you have a logical error because you think you're checking, and well, in effect, you're setting something.
Precisely. So be careful with this. This really does bite beginners, because when you're scanning through your code and you see stuff like this, your head says, yeah, that looks good, because we're checking to see if X equals 5. But remember the way the operators work. The equal operator by itself is an assignment operator, and it is simply saying, take 5 and put that into X. And as Logan says, it's also going to return 5 back. So in this case, we would want to say equals, there we go. Now that is an equality check, and we're saying if X, if whatever is in X is equal to 5, then we're going to return a true. All right, some more relational operators. Let's introduce you to the negation operator. Yay, good fun. So not equals. So if you're able to check if something is equal to something else, you need to be able to also check if something is not equal to something else. And once again, I'm just going to put a couple little marks down here to indicate that we're just going to follow binary all the way down. So the category type here is binary, meaning that we're going to be working on 2 operands. So what would this look like? If x is not equal to 10. Well, what does this return? X is 10, so x is equal to 10. It is not equal to 10. So the answer is no. And what is no? It's going to be false. So this would actually return a false. Okay, the next one we're going to take a look at. Let me just point this out real quick. We will be coming back to the negation operator, which is this cool little guy right here a little bit later on, because it's very powerful. But right now, it does not fit into relational operators unless it is buddied up with our equal symbol for not equals. All right, so moving on down, some simple ones you guys have seen before. How about less than? Once again, it is binary, and a simple example is x less than 10? No, x, which is 10, is equal to 10. Well, I said no again, and anytime you say no, that means the evaluation is going to be to false. All right, so another very simple and common one, greater than. Once again, we're going to be working on 2 operands, so it is of type binary. Is x greater than 10? Once again, no, x is 10. I said no, so it is false. Okay, now, these are going to be very handy here. How about less than or equal to? Notice how I read that. Less than or equal to. Once again, it is also of binary type because it works on 2 operands. Is x less than? No. Or equal? Yes. To 10. Notice I said or in there. I'm throwing some logical operators in just my common speak right now. Is it less than or equal to 10? Well, it is equal to 10. So if either of those 2 conditions met a true positive, like less than or if it was equal, then the whole thing is simply true. So in this case, our answer is true, because x is indeed equal to 10. And now let's go ahead and throw one more in here, and this is going to be greater than. You never saw it coming, did you? Or equal to. Once again, binary, 2 operands, x greater than or equal to 10. And once again, is x equal to 10? Is it equal to 10? Yes. Is it greater than 10? No, but it is equal to 10. So what's our answer, Logan?
True.
You got it. Simple, simple, simple. All right, so hopefully by now you guys see that these terms, unary, binary, and ternary, it's not anything scary and complicated. All we're referring to is how many operands does the operator take. And there's a lot of operators. So far we've taken a look at, find out where my pin's at, and let's switch this back over real quick. We've taken a look at the assignment operator, and we've taken a look at relational operators. Now it's time for us to go ahead and move into some mathematical operators. So once again, let me go ahead and create a new sheet of paper, because we've got a lot of stuff to add here. And let's go ahead and write mathematical. I'm just throwing some words out there. Operators. All right, a lot of these. As a matter of fact, Logan, as I work through these, a couple of these I think we should give some examples on. So, same thing. I want to take a look at the operator. And you know what? I'm going to get real fancy on you here. I'm going to make some straight lines. How about that for being straight? And then I'm going to take a look at the category, because some of these will indeed change. And then let's take a look at an example. And then I'm going to leave the space over to the side wide open, because we're going to need a lot of room for notes. And you know what? While we're in here making this look real nice, let's just do that. And some of you guys might be wondering, why didn't you put this together before? Because right now we're giving regular classroom lecture. This is how I do it in a real classroom if I had students in front of me. I'm writing on the whiteboard. So, All right, mathematical operators. Let's start out with a couple of interesting ones. I'm going to start out with a plus and a minus, but the category type of these operators are going to be unary. So unary and unary, meaning that these guys are not going to be working on two different operands. Now let's go ahead and create some variables. I'm going to have z, I'm going to have x, and I'm going to have y. The only reason my head put them in that order is because I'm thinking of mathematical stuff. It doesn't matter which way they go. They're just variables. They're there to hold information. Also, please don't look at x, y, and z as being some sort of coordinate system. These are variables. Don't allow yourself to get tricked into the dark side and get all confused. Just variables for holding information. Now let's go ahead and stick some values in here. Something like 5 and 2, so that we can follow through our examples and see what we get. So here we go. Let's go ahead and use the plus and minus operators, the unary plus and minus operators. Now, these are going to all be compound expressions that I'm going to draw out because I'm going to write valid lines of code. Okay? Now, an example. Z equals plus x. These two guys are not butted up next together, so it's not like a plus equals that I'm doing. Let's do z equals, well, it wouldn't be because they'd need to be flipped, but you get the idea, minus x.
But nonetheless, you're saying that you've got a space there to visually indicate that they're separate.
Yeah, because a beginner might just look at that and in their head quickly associate it as being a, oh, that's a plus equals. Because maybe they have a little dyslexia going on like I do all the time. And in essence, no, that's not what we're talking about. So what does this mean? Well, the very first one, this does nothing. Oh, that's interesting. It can be useful later. That's all I'm going to say right now. This does something very handy. This is the equivalent. Well, first of all, let's go back to the first line. What would z equals if this line ran? Z is simply going to end up containing whatever is in x. So z would have a 5 in it. Okay, so I'm just going to do that. So that's what happens after that line execute. It's a 5 is in z. Well, what if x contained a negative 5? Well, guess what z would have in it? It would have a negative 5. So whatever is on the right-hand side, when using the plus unary operator, whatever's on the right-hand side is what's going to end up being assigned. That's what it gets evaluated. End of story. But now when we use the negative unary, this is the same thing as doing this. Z equals x times a negative 1. You can see where this is very handy when we need to flip a sign. Okay, so if we need to take something from positive to negative or negative to positive. And you guys have seen this already, as a matter of fact, when we were doing the bounce code in the simple Windows application where we had our button bouncing around the screen. All we needed to do was just negate that particular variable, and now we flipped its sign. If it was negative, it became positive. If it was positive, it became negative. So in this particular case, I'm just going to draw a little line right here. What does z equals if we use our variables up here? If we run this line, x currently contains a 5. That means that z would be containing a negative 5. And if x going in was a negative 5, what would z contain after the line ran? A positive 5. Anything you want to add to that, Logan?
Right. With that drawn out, you can also see why the plus operator by itself does nothing, because if you change that z equals x times negative 1 to say z equals x times positive 1,
absolutely,
then, well, it's still being multiplied by 1, which means it's not going to change the value. Whereas you can see multiplying by negative 1, of course, flips the sign.
You got it. All right, very cool. So these guys, kind of special. Let's just draw a line over here real quick. It's not the same operator if we came in here and used the binary plus and minus. So, of course, again, and now I'm just going to make these little marks here because it's going to be binary as we work our way down for the next few statements. So in this particular case, we simply have expressions that look like z equals x plus y, or z equals x minus y. So what does this look like? It just looks like this. Z equals, well, x contains a 5 plus, and what's in y? A 2. So when we're done, z contains 7. Simple addition. That's all this is. Moving on to the next one. What does it look like? We have z equals what is in x? A 5 minus what is in y? A 2. When that line evaluates, what ends up being in z? Z now equals a 3. Simple mathematics. So I'm not going to drive this in. Everybody should have this concept down with no problem. I just want you to be aware that this plus and minus operator are binary operators. They're expecting 2 operands. And guess what? They're getting 2 operands. So moving on, we also are going to have other mathematical things that you guys are going to use often. You should recognize these quickly. So let's go ahead and do multiply and divide. So and so. So this is just saying z equals x times at y. And this is going to be z equals x divided by y. Simple enough, okay? And now how this resolves, well, the division here, simple. I mean, it all depends on what kind of variables you have. So when you're working with an integer, you can't have the division in there. The decimal in there. So in this particular case, x divided by y would be 5 divided by 2. Well, 5 is not easily divisible by 2, not without introducing a decimal. Correct, Logan?
Right, and so what's going to happen, like you're saying, it all depends on the types that you were using to divide by. The division is simply going to apply to those types, where if you're using integers, you'll get back whole numbers, and it will sometimes have to drop a decimal. So keep in mind that it truncates rather than rounds.
That's right.
So any form of remainder you had will simply be discarded.
That's right. So what's he talking about with truncate? Well, if you had 3.68, if you were to truncate everything past the decimal, this would just be 3. Okay? There is no rounding there. All right, very cool. Now, Logan, what I'd like to do is let's make some people's heads hurt. At this point, we're going to introduce some more unary operators that are very handy. We're going to introduce plus, and I'm going to introduce it in 2 different ways. And we're going to introduce minus, and of course minus. Now, why am I throwing these in here now? Well, first of all, they are mathematical operators. Second of all, they're easy to use if you understand what is happening. Third, I'd like for Logan to be able to start using these right away when he's putting his programs together. And if we know we've introduced them to you, we can use them, okay? So what's going on here? Well, again, these are unary. So let's go ahead and just put one of these in. And same thing, and same thing, okay? An example of what one's going to look like. Well, I'm going to present it to you in 2 different ways. As you see, I'm showing you 2 different sets of the same operators, but it really depends on where do you use them with the operand. So z equals, now we have our operand, so we're going to use x plus. Ooh, let's go ahead and write the other one so nobody gets real confused. X equals plus x. Z equals plus x. Whoa. This is a suffix case where our operator is the suffix to our operand. And this right here is our prefix. Yeah, there we go. Stuff like that. Prefix. You start talking for so long, right? And all of a sudden your head just jumbles up with this just massive traffic jam. All right, what does this mean? Well, we have shown you, let me go ahead and make a little bit of room here. We have shown you in the past this nice guy. X plus equals. See, I'm still clearing out the traffic jam in my head.
Wait, what's the plus 5 operator?
So x plus equals 5, right? And I told you guys that this right here was a lazy way of saying x equals x plus 5. Very handy stuff. Well, when we start using the plus and the minus operators, you're going to find yourself writing code and needing to increment variables by a value of 1 or decrement variables by a value of 1 often, like with counters and things like that. So if we needed to find a way to say x equals x plus 1, we could have simply done this right here, said x plus equals 1, or we could simplify it even more by simply doing this, x plus plus terminator. And that is simply saying take what is currently in the variable x, increment it by 1, and put it back in the variable x. All right, that's all fine and dandy. But why a suffix and a prefix? Well, this is where it's going to get fun. When are we going to increment that variable? That is the question. So let me clear out a little bit of room and give you guys some examples. Then I'm actually going to ask Logan to go over into Visual Studio and show this to you. So let's say that we had, let me think how I want to show this. Well, first of all, I'm thinking, Logan, you got any thoughts on how we can draw this out? You know, that traffic jam, I'm still recovering. Well, first of all, just the simple, z equals x plus plus. And the other way, all that's going to result in both cases is we have a 5 in x, right? So, well, actually, no, it is going to be different. So this does work for me. There we go. So in this particular case, so plus plus comes after. So it's the suffix of after x. So what happens is the value of x is placed into z first, and then x is incremented. Okay? Hence, suffix. So increment it after we evaluate the line. So in this particular case, by the way, let me pause for just a second. Logan, just so you know what I was thinking just a second ago before I decided to actually draw this out, is I was going to show them something more complex where I was going to actually create a compound expression on the right-hand side of the assignment operator where I was going to do some other math too.
Oh, nice.
I don't think they're quite ready for that yet until we start talking about some other things. But in this particular case, if we evaluate it, the first thing that happens is z gets a 5 in it, and then x gets incremented by 1 to become 6. So if Logan was to put this together and write out the result, since the plus plus came after x, we take the value of x, we put that into z, so z becomes 5 because that is what x currently contains. Again, look back up here. And then after we do that, the very last thing we do once we've done everything on the line is we simply increment x by 1. That is why x equals 6. So Logan, if I can get you real quick, let's set this scenario up and prove that to him.
Okay. Let's start with a console app, just something very simple so we can put the scenario together. So inside of our console app, I'm going to jump into main, and then let's set up the same scenario you had on the whiteboard. Let's make a few integers. We'll make an int x, and we'll initialize it to 5. Just like you had drawn on the board, you had 5 or x starting out as 5. Now let's also make an integer for z, though we shouldn't have to initialize this yet because we're just going to turn around and store stuff in it. So what you had written out was z equals x plus plus.
Yep.
All right. Now we need to show these values, so we'll use our console to write out some lines. And first we'll write out z, because that's the order that you had on the whiteboard.
Okay.
And then we'll also write out x.
Okay. So again, in this particular case, before, oh yeah, go ahead and do a read line in there just so we know it's going to pause for us.
Okay. Console.readline. All right.
All right. Now, again, let me review. X gets assigned 5. Z is initialized but unassigned at the moment. Z equals x plus plus. Since the plus plus comes after the x, the value that is in x gets put over into z. Okay? So what is in x at the moment? 5. So 5 gets put into z. Now that means that the line has evaluated. Well, now we need to come in here and take care of this plus plus action. So z contains 5. Let's take x, which is 5, and increment it by 1. And that becomes 6. And let's make sure that is stored in x so that when we write lines here, we're first going to write out a 5, and then we're going to write out a 6, because that is what is in z and x respectively. So let's go ahead and execute this. Look at that. 5, 6. Beautiful. All right, go ahead and close that. Now let's jump back over here to our whiteboard. And let's do the prefix way. So exact same thing. Z equals, but this time, let's do a prefix plus plus x. Terminator. So what happens when this executes? Well, the plus plus operator has one of the highest levels of operator precedence out there. which means that before this line evaluates, the first thing that we want to do is jump in here and increment x by 1. And of course the result is stored back into x. So what is x? Well, starting out, x is, again, it's a 5. So if we increment x, it becomes a 6. So what's going to happen here? Z equals, x equals, we'll keep the same order. So x has been incremented to 6. Now we take what is in x, which is a 6, and we put that over into z. So z equals 6. So you can see the result here by using the prefix method is definitely different than using the suffix method. So Logan, let me go ahead and get you to do the prefix method by putting the plus plus in front of x and see if we can produce 2 6s on our console.
So we'll simply take the plus plus operator, place that in front of x, and run.
And look at that, 6 and 6. Very nice. Okay, go ahead and close that for me. So let me jump back over here to the whiteboard real quick. Why would we have these 2 operators available for us to use in these 2 different ways, excuse me? Simple. You may find yourself, and you will find yourself, in situations in code where you need to use what is currently in x, but you also need to increment it. But you need to use its current value first and then increment it. Well, then you can use the suffix plus plus. And if you find yourself in a situation where you need to increment what is in x, but you need to increment it first and then use it, then you can use the prefix plus plus. Anything you want to add to that, Logan?
No, I think that pretty much sums it up. Again, just it's kind of like a shorthand where instead of having to use and then turn around on a separate line and assign that incremented value to x, it makes it a lot easier because now the expression can be written out on one line in a way that makes sense.
Exactly. Please play with this. If right now you feel a little bit confused, go over, create a simple console application like Logan did, and play with this. It will start to sink in. Very important that you understand the plus plus. Now, the minus minus works the exact same way. So we're going to come in here and say z equals x minus minus, and z equals minus minus x. Both valid lines. Again, same exact thing where we have it being used as a suffix and a prefix. And again, we're just simply taking a look. The very first one, we start out, what is in x? X is a 5. Let's go ahead and just jump in here real fast and take out the plus plus and the plus plus. Let's get rid of these, and we can just walk through it real quick. So if x was used as a suffix and a prefix, what would our results be? Well, in this particular case, we're going to take what is in x and put it into z first, because we don't decrement until after the line is done, because it comes after the operand. Okay, so use that to help you remember when this actually is going to evaluate this expression right there. So x minus minus, so z is going to contain a 5, and then what is going to happen to x? Well, after the line is done, x then decrements by a value of 1, bringing us to a 4. Logan, if you want to set that one up real quick to show them.
Alright, let's take our test with x here, and it changes so that we have x minus minus.
Okay, and let's run it. And look at that, 5, 4, just like on the whiteboard. Okay, go ahead and close that. And jumping back over real quick to our whiteboard. Same thing down here. Now, the minus minus comes first. It's our prefix, which means take care of evaluating this expression first. So because, again, highest order of precedence, the prefix plus plus and minus minus. So what is in x at the moment? Again, x contains a 5. So if we take 5 and subtract 1 or decrement it down by 1, we now end up with a 4. So we know that's what's going to go into x. Now we can finish the rest of the line. So what happens? That 4 goes over into z. So we end up with 4 and 4. So let's go ahead and run that.
Alright, let's change this over to the other side. So we have minus minus as a prefix to x, and if we run, we get 4 and 4.
Beautiful stuff. All right, there we go. Now, if you still find yourself a little bit confused, as I said, I suggest going over into Visual Studio and writing a very simple console application and testing this out. And then after that, if you kind of have an idea of what's going on, don't worry. as we begin using this later on in time, it's going to start becoming more and more clear as to why we would want these operators. Again, incrementing and decrementing by a value of 1 is a very common practice when writing applications. Okay, so now that we've looked at those, let me go ahead and come over here and draw a line real quick. I'm going to extend these if you guys don't mind. I got all sorts of stuff I want to show you. I figure the more I can throw in here, the better, right? So that one didn't turn out real pretty, but that'll work. Okay, so the next one I'm going to show you, modulus. Now, modulus is a binary operator type. That means we all know that it is going to be looking for 2 operands. So let's go ahead and set up an example. Ooh, let me fix my z. That looked bad. All right, so z equals x modulus y. Oh, all right, that just looks really confusing. What's going on? Well, let me make some room real quick. You're going to see modulus used a lot, and I'm going to give you the simple down and dirty to it right here, and I'm going to show you what is happening internally. But there is a pattern that gets generated from modulus, and we're going to explore that a little bit later on in time. So right now you may think, well, that's kind of neat that it does that, but why is it important? Later, when that pattern becomes important to us, we'll start talking about it in a lot more depth then. But what's going on right here when I have a case of z equals x modulus y? Well, this is the same thing as saying x divided by y, our remainder gets put over into z. So let's go ahead and write this out. So if we had 5 divided by 2, all right, let's write this another way. So now we got 2 going into 5. 2 goes into 5 how many times, Logan?
2 times.
2 times. The result is 4. What is our remainder?
1.
1. So what gets put over into z? Our remainder does. So in this particular case, a 1 is what ends up in z after doing that right there.
And if you remember when we were talking about division, we were saying that in the case of integer division, you would lose the remainder. This is a way where you can retain it. You might be thinking that you don't want to lose the remainder. You might want to factor that into your program somehow. This is one way you could do it. If you were dividing integers but needed to account for the remainder as well, you could then run modulus on your division and store the remainder somewhere or do whatever you needed to do with it.
Precisely. And you get a very nifty little counter as well, if you will. I'm kind of jumping ahead here. When using modulus, and we'll talk about that later, but in this particular case, how we're doing a modulus, let's say modulus 2, you can end up in a situation where you get 0, 1, 0, 1. Or if we had a modulus 4, we'd get 0, 1, 2, 3, 0, 1, 2, 3. And this can be very handy in applications.
Right, it's an interesting principle where you can use it to generate repeating sequences of numbers.
Exactly. So we'll come back to it, but you've now seen it, and you see how it works. Basically, what we're going to do is divide the numbers out, take the remainder, and put that into wherever we're assigning the value. All right, so that's modulus, and from here, we're just going to wrap up the rest of our mathematical operators with some mathematical assignment operators, and you have already seen these. We're going to take a look at plus equals, minus equals, multiplication equals, divide equals, and you also have modulus equals, though we're not going to cover that here, but I'm just going to throw it out there. So again, these are all of type binary, and all the way on down. And what does it look like? You guys have already seen this. So z plus equals x. And what does that do? Well, let's go ahead and come over here and give ourselves, even though we've already looked at this once, we'll look at it for one final time. As I clear away a little bit of space. All right, so plus equals x. So z plus z. Z plus equals x. This is just simply saying take what is in z. So let's say z contained a 3. So z equals z plus x. 3 plus 5 becomes 8. 8 is then assigned back into z. It is just a very quick way of saying, all right, this variable, take what's currently in it and do some sort of mathematics. It could be plus, minus, multiply, or divide. And then take the result and put it back in here, but without typing the long version out. And what do I mean by that? Long version, short version. Logan, anything you want to add to that?
It helps sometimes in coding because you might be thinking, okay, I need to add 5 to z. And so you think, okay, z plus equals 5, and it just does that. The thinking about the words that way makes times equals and divide by equals a little bit more complicated because you don't usually say, all right, times 5 into z or anything like that.
Right.
But I mean, it does operate on the same principle. And once you understand and see the convenience of the principle, then you can see where it'd be handy to have that for all mathematical operations.
You got it. So I'm just going to scribble these out real quick. So it would be z minus equals x. It would be z times equals x, and z divide equals x. That's the way they look. And again, it's the exact same thing. So if you wrote it all out, it would be z equals z, and then whatever in here. And I'll just throw times as an example, times x. So if z contained a 3, as the example I drawn above, and x contained a 5, then you would end up with 15 being stored over here in z. Simple enough?
Right, very, very simple and just a nice shorthand way of doing things.
Okay, so that's going to, and again, these are, like I said, these are both mathematical and assignment in nature because they are performing a mathematical operation and then assigning the result back into the variable. We're almost done, believe it or not. There's just one more thing that I would like to mention before we get into operator precedence, and that is logical operators. And logical operators, and I remember I said I would use the whiteboard to just take 2 seconds to draw out a quick example of what I was talking about. Well, allow me to do that real quick just so that we have indeed mentioned it. So, logical operators. Let me throw my L in there because it looks funny. So logical operators get into things like the ability to negate. That is an exclamation point, so I'll do that to help see it. And, or, just in case you've seen these symbols. And then short circuit and, short circuit or. Heck, we can go ahead and throw the XOR, the exclusive OR, in there as well. There you go. So let's just pick on one of these guys. Let's take this guy right here as a quick example. He is of type binary. Remember how we had that little if example earlier, and I said use that when we were talking about the relational operators? Well, just try to picture that real quick, where if we said if, and now we're going to put something inside here, because we need this to evaluate to a true or a false, and that's what we're going to get out of here. We're going to get a true or a false. So, an example would be if x is equal to 5 and y is less than 10. Da-na-na. There is a logical expression. This just basically says, if x is equal to 5, set it to true. If it's not equal to 5, set it to false. If y is less than 10, set it to true. If y is not less than 10, set it to false. Now, we end up with our result. It works on 2 operands, so we've got true, true. In this particular case, you would read it like, if true and true, then the whole thing is going to evaluate to true. Okay? So in this particular case, if this first one, evaluate it to a false. Now, I don't want to get into short-circuiting and all that right now, but in this particular case, using the double ampersand signs right there, is there any reason to even check this side? Because we already know it's going to fail. Because the way this AND works is both of these sides have to be true. Well, one of them's already failed, and since both has to be true, there's no reason to check this side. The result is going to be false. Now, right now, some of you might be watching this going, whoa! You just blew my mind. And if I did that, that's okay. We're going to come back and visit this with a lot of examples. But again, I really would like for us to get into the if statements first. And then you'd really start to understand the power of where logical operators lie. Okay? Sound good to you, Larry?
Right. It also makes explaining the terminology a little bit easier when you think of something like compound cases where if this and this, because that's a check you might need to actually have happen, something where you need multiple things to be true before something continues.
You got it.
But again, that makes more sense if you explain it all out using if.
Yep. All right, so with that, let's go ahead and we got to start wrapping this up soon. We've been going on forever. Let's throw one more sheet in there, and this is going to be our operator order of precedence. What is he talking about? That sounds kind of scary. This is very important stuff here. Let's say I had a situation where I said x equals 5 plus 3 times 6. Yeah, let's just go with that right there. Something really simple. Order of precedence with these operators is very important because it really defines how your expressions are evaluated. In this case, if you're not thinking back to your old days at school with mathematics, you might get yourself in trouble quickly. Some beginners like to just start from left to right and work their way over. And in this particular case, this would fail on you miserably because you'd come in here and say, all right, so 5 plus 3 is 8 multiplied by 6 gives you this great big number. All right. If we did this properly and we followed order of precedence, multiplication has a higher order of precedence than the addition operator does. So in that particular case, we'd have 3 times 6 gives us 18 and add 5 to it. A completely different number than what you'd get if you just worked from left to right. Right, Logan?
Exactly. If you had done that left to right, like you were talking before, you would end up with 8, and then 8 times 6 would give you 48. So your final result would be 48. But to do that properly, you'd have to take into account that multiplication has higher order of precedence. That means you would first do 3 times 6.
Give an 18.
Get 18. Then you'd have to have 5 to that and get what? 23.
Yep.
So you have two different results.
23 or 48. Whoa, that if you're expecting 48 and you're not getting 48, yeah, that's because you're not really paying very close attention to the order of precedence here. And let's say that we had z, and z up here was equal to 2. Another example, if we set x equals 5 plus z. How does that solve out? Well, go ahead, Logan.
Well, the prefix plus operator happens before any of that, even before the assignment. So the very first thing you do would be to increment z. So z would become 3.
That's right.
Then you would add it to 5 to get 8, and finally you take 8 and store it in x.
That's exactly right. And that is what gets put into here. Again, you can get yourself in trouble. This exact same situation, if the pluses were on the other side of z, you'd end up with a different result because it would then be 5 plus 2, giving you 7 back in x, and then z gets incremented to 8.
Which would be tricky there because in both cases, after that line executes, z would have the same value, irrelevant whether you did the prefix or suffix.
But x would be walking away with a different value in both cases.
Exactly.
All right, so order of precedence, just to cover them real quick, what I want to do is go from I'm just going to draw a nice little line right here because I'm all about these lines today. Let's go ahead and start at our highest, if I can spell, and we'll work our way down to the lowest. Well, right off the bat, the highest is going to be plus plus and minus minus when used as prefixes. And then, of course, another huge one that you can't forget about, parentheses, because parentheses allow us to group things together. Remember this example right here? What took place first? The multiplication, so 3 times 6. But if we put these parentheses in here, whoa, that has a higher order of precedence than the multiplication. And here's how I can prove that. The very next thing is going to be multiply, divide, or modulus. So in this case, we would come in and say 5 plus 3 is 8 times 6. Okay? So you can see if we needed this to occur first in our first example that we gave you, we simply put these inside of parentheses. And then this would get evaluated before we evaluate the expression using the multiplication operator. Okay? So like I said, multiply, divide, and modulus. What order do these work in since they all appear on the same line? Left to right. So again, now we're going to come back over here to this left to right. And if we have, 2 times 6 divided by 4, you're just going to work your way right across. So 2 times 6 is going to give you 12, divided by 4 gives you 3. Okay? Now, after we have our multiply, divide, and modulus, the next thing we're going to get is going to be our simple addition and subtraction. Now, let me revisit. I'm going to throw one more thing up here. Since they've seen it, I don't think it'd be a bad thing to throw this up there. The unary versions of plus and minus. How about that? Remember, that's like taking it and multiplying it by a positive 1 or taking a value and multiplying it by a negative 1. So that's going to be all the way up there at the highest level as well. Moving down from there, we're now going to see less than, greater than, less than, equal to, greater than, equal to. So some relational operators. Now we're going to see equals. And we're going to see not equals. Moving on down from there, we're going to see equals. And now these are all of our mathematical assignment operators. So we'll see multiply equals, divide equals, modulus equals, and then finally getting over to our plus equals and our minus equals. There we go. And then at the very bottom, hopefully by now, you've been able to guess it. As a matter of fact, if you want to pause the video and see if you can guess this, do it right now. Okay, here's the answer. The answer is going to be plus plus and minus minus again, but in this case, they are both being used as suffixes. There you go. If I can finish spelling it all out. Why? Because the whole line evaluates. After the line evaluates, then that number is incremented by 1 or decremented by 1. Okay, that's why it is the lowest operator order of precedence. Okay, now check this out. Just to prove something to you, remember how this equal sign is like one of the last things that takes place? Isn't that awesome? You can actually see it right here in the operator order of precedence chart. It's because it's way down here. So all of this cool mathematical stuff that we were doing right here, all of that had a higher order of precedence. So all of that got evaluated until we were left with x equals, and then of course the result on the right hand side, and then, well, there's our equal. It's way on down the list. And so we had the assignment take place. So you can actually see how it all lays out here. It's really cool.
It's also why we don't have to group everything in parentheses.
Yeah.
If we just had some simple mathematical expression, because all the mathematical operators are on a higher order of precedence than the assignment, the math happens first and the assignment happens after the math is done.
Exactly.
That also explains why it looks like when you use plus plus or increment and decrement as suffixes, why it looks like those don't run until the line is done, is because even the assignment finishes before the suffix increment or decrement is evaluated.
Precisely. And with that, Logan, I think that pretty much hits on all of the operators I want to cover here, which is most of them. There are a few more out there, and we're going to be talking about the logical operators as well, and we'll talk about these in upcoming videos. Anything you want to add to this?
I think that sums it up pretty well. Again, you've covered quite a few of the operators, and we've gone over unary and binary and order of precedence. So I think that has everything wrapped up.
Well, ladies and gentlemen, the most important thing that you should be walking away from this video with is what an expression is. It's a combination of literal values, variables, and operators that are evaluated to a result, and we have seen that over and over. We also talked about what an operand was. It's literal values, it's variables that are used with the operators to form expressions. We talked about how operators broke down into 3 different categories: unary, binary, and ternary. Even though we haven't given a ternary example, we'll do that soon, coming up. Because that does get a lot more confusing in comparison to everything that you have seen so far. But basically, with the unary, binary, and ternary, it's talking about how many operands are involved with that particular operator. So with that, that is going to wrap up this video on expressions and operators. Thanks a lot.